Hi guys, let me get the host access, then we'll start the class. Did you guys try solving problems from Parabola NCRT? Bhaskar, can you give me access of host? Yeah, please do it. Yes, did you try solving? Anyone? Mitran, Ashwin, Hari Raghav.
Sir, yes, sir.
Did you try solving? Are you having any problem? I just try to solve question number 12 of exercise 11.2. Everyone try to solve it. See, till I get host access, please solve it. I'll share my screen. Yeah, hi Appu will have at 7:30. Okay, will that be okay? Eight you have class. Okay, so what we'll do, I'll try to start at 7:15 until 8 we'll have. Okay, will that work? Thank you. Okay, sure. Okay, Hariharan. Okay, everyone try to solve problem from exercise 11.2, question number 12. Okay. Okay, I'll be sharing the screen. Can you guys see the screen?
Yes, sir.
Okay, so we were studying coding section. So try to solve that problem. Do you guys have any doubt in this conic section? Any problem or anything you know about parabola? See, in question number 12, try to solve. Everyone, please try to solve. See, the vertex is given. Vertex is 0, 0. Okay, and passing through points. There is some point. It is passing through some point P. Okay, some point. It is passing through point 5, 2. Okay, and symmetric with respect to y-axis. Symmetric with y-axis. Okay. See, parabola, for parabola, was the property, its distance from directrix, perpendicular distance from directrix is 1. The ratio of perpendicular directrix is 1. That means this. That means if PS is always equal to PM in this case, this and this should always be equal. Even if P is here, Okay, the meaning is if P is here, that means if you draw a perpendicular from here, and if this point is M, so this line will be equal to this line. Then it is called a parabola. Okay. Now find out symmetric to y-axis meaning what? This is your y and x symmetric to y-axis. That means it is something like this. Because the vertex is at 0, 0, that means the parabola is somewhat like this or somewhat like this. It can be like this or this, but it is again passing through point 5,2. So if the parabola is downward, it cannot pass through point 5,2. It has to be this parabola. Okay, so the parabola is this one. Now this parabola we defined by x square is equal to 4ay, right? So these are the hints I'm giving you. Try to do it.
Sir, it's 25 y by 2.
What?
Sir, x square is 25 y by 2. Sir.
X square is equal to
25 y by 2.
okay, yeah, okay, correct. So you got it. How you will solve it? See, everyone, please try to understand this. Whenever you are given any equation, right? So first, always draw the graph. Not just for reference. This is just a reference graph, not the actual graph. Okay. So this is your y, and this is x. Now it said the vertex is here at the origin. So point A is here at the vertex. Okay, at the origin vertex. Now it is passing through some point 5, 2. Some point P is 5, 2. Okay, it is said that it is symmetric with y-axis. Okay, if it is symmetric with y-axis, that means the graph will be something like this. It cannot be the downward graph. Why? Because it will not pass through this point P. Okay, so this graph is not possible. This parabola is not possible. And we know if a parabola is like this, it is x square is equal to 4ay, right? 4ay. Now you just need to find the value of a, isn't it? Yes or no?
Sir, yes, sir.
Yeah. So since it is passing through point 5, 2, that means it will satisfy this point. So plug point P, that is 5, 2 in x square is equal to 4ay. That means x is how much? 5. 5 square is equal to 4 times of a into y. Y is how much? 2. Right? So from here you'll get the value of a. A will be equal to 25 upon 8. Okay, you got the value of a. Now plug this value of a here. So what you'll get? X square is equal to 4 times of 25 upon 8 into y. So x square will be equal to 25 upon 2y. So this is your answer. Got it? Anyone is having doubt here?
Sir.
Are you sure? Okay, let me give you one problem. How many of you are here? Shri Kruti, you there? Okay. So see, it's you guys are joining one class again, absent in another class. So better not to take class. Anyway. Okay. Let's see if we can solve this question. See, the extreme points of latus rectum. What is latus rectum? Anyone? Huh?
So the 90 degrees, sir.
No, not just 90 degrees. See, if there is a parabola and the latus rectum, the focal chord, which makes 90 degree with its axis, that is called latus rectum. Okay, it's not just 90 degree. What is 90 degree? See, if this is some parabola, let's draw some random parabola. This is some random parabola. Okay, now suppose here it is x and y, x and y. So if this is the axis of parabola. So this is the axis of parabola. So this point will be vertex. So directrix will be somewhere here, right? And this is the focus. Now the chord, the focal chord, this is the focal chord which makes 90 degree with its axis. This is called latus rectum. Okay. Now the extreme points of latus rectum is given. So this point P, it is given for 7, 5, and this point Q is given 7, 3. Okay. This is given to you. Now find the equation of parabola. Can you find the equation of parabola? See, focus of the parabola is always the midpoint of latus rectum. Write down a point, write down everyone. Focus of a parabola is always the midpoint of latus rectum, right? Focus is here. So can you find the focus? This is dividing in the ratio of 1 by 1. Can you find the midpoint? What will be the length of latus rectum, anyone? Length of latus rectum. See, this is the extreme point. So the distance you have to find from PQ, that is PQ, which is equal to what? It will be 2 unit. 5 minus 3, that will be 2 unit. Isn't it? Yes or no?
Sir, yes, sir.
Okay. See, the axis of parabola is all perpendicular to this latus rectum, isn't it? Huh? This is the axis of parabola. This is perpendicular to the latus rectum. So if you find its equation, you can write y minus 4 is equal to 0 upon 5 minus 3. This is the slope into x minus 7. Why it is 0? Okay. 0 is 7 minus 7 actually. 7 minus 7. This is the slope. Y is equal to mx plus c. So what you'll get, y is equal to 4 is the latus rectum. So this is the equation of latus rectum. Yes?
Sir.
You have got the equation of latus rectum. So what will be the equation of directrix? Is it too much? Okay, leave it, leave it, leave it. This is not anyway in your syllabus, so leave it. Let's start. So can you solve all the problems from NCERT at least? This exercise 11.2, it is very easy, right? Whatever we have done, we have solved all types of problems. So let's jump to ellipse. The third type of conic section, ellipse. Okay, so this is the third type of conic section. Okay, third type of conic section. Now, what is ellipse? Can anyone define ellipse?
Oval shape, sir.
Huh?
That's an oval shape, sir.
Oval is an ellipse. Is oval shape? What is? How do you define oval shape? Oval is an ellipse. So how you will define oval?
Elongated circles.
Uh-huh.
Elongated circles, sir.
See, we have particular definitions, right? Like for circles, we have a definition that if it's from its center, it's a, if you have, it is always, it traces this point P, will always trace the equal distance from this point center, right? So this distance is always equal. The locus of point P. P will move such that PC will always remain constant. That is the definition of circle. Now, when we were studying parabola, we studied that its distance from focus to any point on parabola, like this is focus of parabola, PM. And if you draw a directrix 90 degree to this line, and let's say this point is M, so PF is equal to PM. Okay. See, I told you yesterday the definition of conic section. Okay. Conic section, that means if you have any point, let's say it is called focus, and it's a fixed point. Focus is a fixed point. If you draw, and now there is a point somewhere in space, let's say that point is Q. Okay. Now this Q will move such that if you join FQ and draw a perpendicular from FQ to some line. Okay, so this is the this line is called directrix. The ratio of the ratio of FQ upon QM is always constant. That is called parabola. That is called conic section. Now, when this constant is actually called eccentricity E. Okay, if this eccentricity, if E is equal to 1, it is called parabola. Okay, when E is less than 1, okay, when this ratio is less than 1, it is called ellipse. It will trace an ellipse. When E is greater than 1, it will be hyperbola. Understood? Understood or not? Yes or no? This line is directrix. So this ratio, always look for this ratio. It is called eccentricity. Okay. So write down the definition of ellipse. Ellipse, it's a locus of a point. Let me write. I will define it. Okay. So let me write the definition. It's the locus of a point which moves in such a way that the ratio of its distance from the focus from a fixed point, or let's say from a fixed point, which is called focus, from a fixed point and perpendicular distance from a fixed line. What is this fixed line called? Huh? What is this fixed line called? Directrix. Fixed line is constant and is constant, which is denoted by E, eccentricity, and less than 1. That means eccentricity is less than 1. Then we call it a ellipse or an ellipse. Understood? Understood or not? See, suppose this is a line, some line, the directrix. Suppose this is the directrix, okay, and it's we have a the focus is here. Say This S is the focus. P comma B is S. Okay. And point P is moving such that this is point P. Okay. The point P, let's say point P is such that if you draw a line from PS, so this line is passing through the focus and perpendicular to the directrix. Okay, so let's say this is M. Right, now this is perpendicular to directrix. This is called directrix, which is fixed line. This S is called focus, which is fixed point. This P is any point which is moving in space, moving in XY plane. Okay, and it is perpendicular to directrix. So the ratio of which ratio? SP upon PM is equal to E, which is less than 1. Okay, so SP is always less than PM. That means point P is always closer to the focus as compared to the directrix. Understood? Point P is always closer to the focus S as compared to the directrix. Understood? In case of hyperbola, it is exactly opposite. P will be closer to directrix as compared to focus. Okay, P will move such that. Is this definition clear to you? Understood? Now, if you trace this P, you will always get an ellipse. Okay, you will always get, sorry. If you trace this P, so if you trace this P, you will always get ellipse like that, something like that. Understood? So P will move on this path. Got it? We'll see about this in a minute. Okay. Understood? Yes or no? So for an ellipse, yeah. So an ellipse, for ellipse will have two focuses. Okay, two foci, or we say foci or foci. It's up to you how do you pronounce. That means there will be two focus, F1 and F2. Okay. So let's have standard equation of ellipse. See, you don't have to study general equations. I'm not giving you general equation. I have not even given general equation of parabola because we are going through NCERT. So we'll only study standard equation. Standard equation of an ellipse. Okay. So standard equation of ellipse is x square upon a square plus y square upon b square is equal to 1. This is your ellipse. A is always greater than B. A is always greater than B. We'll see what is A, what is B. Okay. Understood? And B square is equal to A square into 1 minus E square. E is your eccentricity. Okay. E is always greater than 0 and lesser than 1. The value of E is always lesser than 1 and greater than 0. Understood? Let's see the terminologies related with standard equation of ellipse. So let's say this is an ellipse. Okay. See, I'm drawing this ellipse. Let's be clear, I'm drawing only this ellipse, not the general equation. So the center of this ellipse is on the origin. Okay, so we are talking about this ellipse. This is y, this is x. Okay. Now these points are called vertex of ellipse. All right. We'll have two focus. Let's say this is F1 and this is F2 or S1 and S2. That's right. Sorry. S1, S2. So these are the two focuses. Now, what is A? A is called semi-major axis. So this is A. From here to here, this is A. This point is called A. And from here to here, this is also A. This is semi-major axis. And semi-minor axis, that means this one. This length is called B. Okay. This again is B. I don't want to write inside, so I'll just write it here. Understood? So this is B. This is also B. From here to here, it is A. This is also A. Okay. Now focus. So focus 1 and focus 2 can be, so because this point is the origin, 0, 0, center. Let's say C is the center. S1 will be given by, S1 is minus A times of E, comma 0. This is plus A times of E, comma 0. So these are the focuses. These are the coordinates of S1 and S2. All right. So directrix, let's draw the directrix. So directrix will be here. Somewhat around, like, let's say. So this is first directrix. This is another directrix. So there will be two directrix, and the equation of this directrix x is equal to A upon E. This is x is equal to minus A upon E. Okay, directrix. Got it? What will be the coordinate of this point and this point? Anyone? And this point, what will be the coordinate? Let's say this is point P, Q, R, S. What is the coordinate of point P? Yes, anyone, please tell me the coordinate of point P. See, this length is A, right? This length from here to here, it is A and it is on x-axis. So what will be the coordinate of P?
Sir, A comma 0.
Yes, A comma 0, very good. What will be the coordinate of Q? Hari? From here to here, it is B, no? So what will be the coordinate of Q?
0,
Sir, 0 comma B.
0 comma B. S?
0 comma minus B, sir.
0 comma minus, very good. R?
0, minus A comma 0, sir.
Minus A comma 0. What is S1? S1 is first focus, okay? Minus AE comma 0. Can you see this?
Sir.
Okay. And S2 is your second focus, which is AE comma 0. That means the distance from here to here, it is AE. Distance from here to here, it is also AE. Okay. Understood? So let me write it again. So first point A is focus or foci, that's right. S1 is minus AE comma 0 and S2. You can name any S1, S2, doesn't matter. AE comma 0. It is on x-axis, obviously. Number B, equation of directrix. Equation of directrix, yes. X is equal to AE and the second directrix will be x is equal to minus AE upon E. Okay, C. What is third point? Vertices. Where are the vertices? Vertices, let's say this point, where is it? R and P are the vertices, isn't it? So R, P and R. Okay, so P is A comma 0. R is minus A comma 0. Fine. Yes? Yes or no? Anyone? Please tell me if there is any doubt. See, now the chord, if you draw a chord, let's use red ink for that. If you draw a chord, so it should pass through the center, okay? So let's say if you are drawing a line, something like this. So this is called the chord of conic or chord of ellipse. Do we have to study chord of ellipse? Let me check. No, we don't have, as of now, we don't have that chord. Okay, latus rectum. What is latus rectum? A chord which is perpendicular, right? It has to pass through focus and is perpendicular. This one, this and this is your latus rectum. There are two latus rectum, isn't it? Yes. So these are the latus rectums. Yes or no? Eccentricity. Let me write that. E is the eccentricity or E is equal to square root of 1 minus B square upon A square. This is your eccentricity of, okay. Let's solve problem so that it will get cleared up. We'll discuss few more points in this, but based on these, let's solve some of the problems. Okay, so you are given equation. You are given equation of ellipse x square upon 36 plus y square upon 16 is equal to 1. Okay, so this is given. Now find the eccentricity. Find E. Yes, anyone tell me the value of E? Anyone, please tell me the value of E. Yes, Hari. Tell me the value of E. How you will find E? E, see, first always compare it with standard equation. What is that? X square upon A square plus Y square upon B square is equal to 1. So A square is equal to 36. That means A should be equal to what?
6, sir.
6. Plus or minus 6, but we are only taking the positive value. Okay. Now B will be equal to what? B square is 16. So B
4.
4. Now how you will calculate E, eccentricity? Square root of 1 minus B square upon the A square. Okay, so 1 minus B square is 16 upon 36. How much is that?
20 upon 36, sir.
So root 20 upon 6, isn't it? Root 20, how you can write root 20? 2 root
2 root 5.
2 root 5. So 2 root 5. So root 5 upon 3. Fine. So this is your eccentricity. Now eccentricity is always less than 1 for ellipse. Right? Now find out the focus, the coordinates of focus. Find out. So eccentricity you have got. Very good. Now find the coordinates of focus. So there are two focuses, right? S1, which is AE comma 0, isn't it? A you already know. A is equal to 6. E you already know.
Sir, 2 root 5 comma 0, sir.
Okay. S1 and S2. S2 is what?
Minus 2 root 5 comma 0.
So this will be your A6 into 2 root 5 comma 0, and this is your minus 2 root 5 comma 0. Okay. What else? Coordinates of focus, the vertices. Where is the vertex?
6 comma 0 minus 6 comma 0, sir.
Right. Vertex like P is the vertex, which is A comma 0 and Q minus A comma 0. Q or R, whatever you want, you can write. It doesn't matter. So vertex P is A is how much? 6 comma 0, and this is minus 6 comma 0. Okay, so vertices we have got. Now the major axis. What is the major axis? A is called the major axis. A is major axis and B is minor axis. So you have already got the value of A and B. Eccentricity you have already. Length of latus rectum. So how do you calculate? Okay, I haven't taught you yet. So with this information, can you draw the ellipse? These informations are given to you. Can you draw the ellipse? So suppose if this is your ellipse, suppose this is your ellipse. Of course, its center is at the origin. Okay, so this is Y, this is X. Okay, so this is the ellipse. Now this point is 6, 0. This point is minus 6, 0. The focus is 2 root minus 2 root 5 comma 0. One focus, another focus is 2 root 5 comma 0. Right? This length is of course 6. What will be the coordinate of these 2 points? Anyone? See the coordinate of this, let's say this is P, this is Q, this is R. What will be the coordinate of R? Major axis. How much is the major axis? 4, right? So this will be 0 comma 4. S will be 0 comma minus 4. So this is the ellipse that we want. Now latus rectum, we'll discuss about latus. So latus rectum is a focal chord, the chord that passes through focus, which is perpendicular to its axis. Okay, that means if it makes 90 degrees. So that means if we have two focuses, we'll have two latus rectum and we have two directrix, isn't it? So this is the directrix. Find the equation of directrix. These are the directrix. Tell me the equation of directrix. So this is your one directrix, and here will be your another directrix. Yes. Tell me the equation of directrix. That means you have to find this length. This length is x upon e. Sorry, a upon e. X is equal to a upon x. Sorry, a upon e, and this is also a upon e. This length. So tell me the equation of directrix. Yeah, Shri Kruti, tell me. What will be the equation of these two lines? A upon e is how much? The thing is, value of a is how much? 6. E, how much you got? What is value of e? Root 5 upon 3. So this a upon e is how much? This line is x upon x is equal to minus a upon e. This line is x is equal to a upon e. Right? So x directrix, let's say this is directrix 1. So d1 is equal to x is equal to minus a upon e, which is minus 6 upon root 5 into 3. So minus 18 upon root 5. Okay, and that means the equation of directrix 1, this directrix, this is d1. This will be x plus 18 upon root 5 is equal to 0. Equation of second directrix, let's say this is d2. So d2 is x is equal to a upon e, which is 18 upon root 5. So x minus 18 upon root 5 is equal to 0. Okay, understood? We'll discuss about latus rectum, but first, did you understood about this directrix or not? Is directrix clear? Okay. Tell me if you have doubt, please let me know. Do you have doubt?
No, sir.
Are you sure? Okay. Okay. See, this is one type of ellipse. Okay. Ellipse, we are not studying general equation of ellipse, but only the standard equation, right? Because that's what you need to study, standard equation. So standard equation of ellipse is its center always lie on the origin, right? So this is the center. But ellipse can also be like this, isn't it? This ellipse can be like, see, if ellipse is like this, if you are getting value of a greater than b, okay, if a is greater than b, that means you are getting this ellipse. If a is smaller than b, then you'll get this type of ellipse. Okay, so let's understand that ellipse. Okay, so ellipse of standard equation of ellipse of second type. So this is second type. First type we have already seen. Now let's understand the second type. Okay. So here a is lesser than b. Equation of ellipse is x square upon a square plus y square upon b square is equal to 1. Okay. Eccentric. Okay. This is the ellipse when a is lesser than b. Let's draw the ellipse. First, let's draw the ellipse. So the ellipse will be this shape. Okay. And everything else will just x will convert to y will convert to x. That's it. If you have understood one type of ellipse, that standard equation, you can solve it easily. So this is y, x. Okay. Now, of course, this is b, and this is a. So one focus will be here. Okay, S1, S2. Okay. Now these are the vertex of ellipse. Let's say A is the vertex of ellipse, A and B. So what is the coordinate of A? Anyone? B is 0, minus B. All right. So this is the vertex of ellipse. What will be its focus? Coordinate of focus? It will be 0, b times of e. This will be 0 comma b times of minus b times of e. Okay. How you will write the eccentricity? What is eccentricity? Now let's say this point is C. So the coordinate of C is minus a comma 0 and D is a comma 0. Yes. Now how you will define eccentricity? See, center is always 0 comma 0. We are studying only ellipse whose center is 0 comma 0. Focus we have already written S1, S2. Eccentricity E will be equal to square root of 1 minus a square upon b square. Okay, because a is smaller than b. See here, the eccentricity was b square upon a square. See, square root of 1 minus b square upon a square. This is the eccentricity. Here it will change a square upon b square because the ellipse has changed. Understood? Vertices already we have defined. Equation of lattice rectum. Okay. Now what will be lattice? So this is the lattice rectum here. Lattice rectum always passes through focus and it makes 90 degrees. So this is your lattice rectum. Okay. So this is lattice rectum because this focal chord will make 90 degree angle. Okay. So let's write equation of lattice rectum. Okay. So equation of lattice rectum will be y is equal to plus or minus b times of e because it is passing through that. Okay, here I think we haven't defined lattice rectum, so let's write e equation of lattice rectum. It will be equal to x is equal to plus or minus a times of e. Okay. So that will be the equation of lattice rectum because in this case lattice rectum is this one, these two, these lines. And this line is x is equal to AE because AE you have got AE, right? This is x is equal to AE. This is x is equal to minus AE. Okay, so that's why it is equation of lattice rectum is plus minus AE. Here it is y is equal to plus minus BE. So that is your lattice rectum. What else we have missed? The directrix. Okay, what will be the equation of directrix? Anyone? Let's say that is your directrix 1 and directrix here. So this is your directrix. So equation of directrix is y is equal to plus minus b upon e. Two directrix you have d1 and d2. Okay, so equation of directrix is this, right? Now what will be the length of lattice rectum? Let's say this point, let's use which color? Okay, let's use this. So here this is L. Let's say this is S1 dash or some name. That's right. We have used A, B, C, D, PQ. Let's use PQ. So PQ. What will be the length of PQ? Length of lattice rectum. That is PQ in this case. PQ, how you will find? So it is represented by L of length of lattice rectum. This will be equal to, see, this PQ is also equal to this one, P dash Q dash, right? So PQ is equal to P dash Q dash, which is length of lattice rectum. It is given by 2 times of A square upon B. Okay. You just need to find the length using that formula. What formula? Distance formula. So you need the coordinate of point P and Q, and you can find the lattice vector. So the y coordinate is always BE, you know, you just need to find the x coordinate. How you'll find the x coordinates? Huh? Anyone? How you'll find the length of that this coordinates? Anyone is there or not? Are you guys there in class?
Sir, Rashid.
Yes, sir.
Give a reply. No? How would I know whether you guys are here or not? You think I just keep on talking and all? Shall I do that? Solve a problem. Okay, you are given 16x square plus y square is equal to 16. Okay. Find the coordinates of foci. Find foci, vertices. Find vertices. Length of major. Find A, B, E. Length of lattice vector. Length of lattice vector. Equation of directrix. Equation of lattice vector. Find out. Got it? See, compare it with standard equation. What is the standard equation? X square upon A square plus Y square upon B square is equal to 1. That means in the right hand side, you always need to make it unity. So what you will do, you will divide the equation by 16. So if you divide this equation by 16, what you'll get? So divide it by 16, 16 both sides. What you'll get? X square plus Y square upon 16 is equal to 1, right? So if you compare now these two equations, this equation and this equation, what you're getting, A is equal to 1 and B is equal to 4, right? Because B square, now here you see B is greater than A, right? If B is greater than A, what type of parabola do we have? We have this type of parabola. Where is it? Okay, sorry. This is the parabola. When B is greater than A, right? You see this parabola? A is lesser than B. B is, that means now you have got the value of A. This value you are done with. This value you are done with. Now let's find E. Eccentricity is equal to square root of 1 minus A square upon B square. Okay, so 1 minus 1 upon 16. That will be square root of 15 upon 4. That is your eccentricity. Fine. So this also we are done with. Now foci we need to find S1 and S2. How do you find S1 and S2? That means focus. Okay. So S1, let's say S1 is the focus. It's coordinate. What? How do we find focus here? Now in this S1 is 0 comma BE and 0 comma minus B. So 0 comma BE. Okay. So BE, how do you calculate? B is 4 times root 15 upon how much? 4. So BE is equal to square root of 15. Okay. So focus S1 will be 0 comma root 15 and S2 will be 0 comma minus root 15. Okay. So foci is also done. Of vertices. Vertices. How you find vertices? What are the vertices? A and B. So 0 comma B and 0 comma minus B. So 0 comma B and 0 comma minus B. So 0 comma 4 and 0 comma minus 4. These are the vertices of ellipse. What else do we need to find out? Length of latus rectum. So how do we find the length of latus rectum? It is 2a square upon b. So length of latus rectum is equal to 2 times of a square upon b. Now 2 times a value is 1, b value is how much? 4, right? So this is half unit. That is length of latus rectum. Now equation of directrix. So what will be the equation of directrix? Y is equal to plus minus b upon e. So plus or minus b upon e is what? B is 4 upon e is root 15 upon 4. That is 16 upon root 15. Okay, plus or minus. That means one directrix, let's say D1 is y plus 16 upon root 15 is equal to 0, and D2 is y minus 16 upon root 15 is equal to 0. So these are the two directrix. Also equation of latus rectum. How do you find the equation of latus rectum? So it is y is equal to plus or minus b times of e. That is plus or minus 4 times of root 15 upon 4. That is plus or minus root 15. Okay. So L1, let's say latus rectum 1 is y plus root 15 is equal to 0. L2 is y minus root 15 is equal to 0. So these are the quantities we needed to find out. Understood? Huh? Now, if I ask you to draw the ellipse, how you can draw, you can simply draw the ellipse, right? So this ellipse will look something like that. Now its center is on okay. This is y, x, okay, x and y. Now this is what we have found all. S1 is 0 comma b. So this is S1. This is your S2. This is your L1, L2. Length of latus rectum will be, so this is your directrix. Directrix will be somewhere here and here. These are the two directrix, okay, which is y is equal to 16 upon root 15. This is y is equal to minus 16 upon root 15. Okay. Oof. Something is not correct. plus or minus root 15. Yeah, okay, fine. So L1, so this equation of this line is y is equal to root 15, and equation of this line is y is equal to minus root 15. Understood? And focus, so we have already got. How much is the focus? 0, 15, 0, comma 15, and S2 is 0, comma minus 15. Square root of 15, not 15. Vertices also we have got this point and this point. Also we know this point, and this point is the origin. Okay, solve next problem. Okay, solve question number 10. Exercise 11.3. Solve question number 10. So vertices are given, that is plus or minus 5 upon 0, and you are given the foci or foci plus or minus 4 upon 0. Now you find the equation of ellipse. Find the equation of ellipse. Find it. See, if foci is 4 plus or minus, that means it lies on x-axis. Both are on x-axis. Both lies on x-axis. It's given in the problem, right? So if you, we know what is vertices. If you compare vertices are given by plus or minus a comma 0, right? Isn't it? Plus or minus a comma 0, that means value of a is 5. Okay. Foci is given by plus or minus ae comma 0. So ae is equal to 4. A already we know, so e will be equal to 4 upon 5, which is less than 1, of course, because it's an ellipse. Now we know eccentricity e is equal to square root of 1 minus b square upon a square, right? Because this is the ellipse on x-axis. Okay, so from here you will find the value of b. How? So it is e square. You can write b square minus a square will be equal to 1 minus e square. Okay, so b square will be equal to 1 minus e square. E is 16 upon 25, right? Isn't it? And b square upon e square. So let's square root this one. Okay, and you multiply it with a. A is how much? 5. All right. So this will be not b square, this is b. Okay, b is equal to, what I have done here, I have written b by a whole square is equal to 1 minus e square. So b by a will be equal to square root of 1 minus e square. So b will be equal to a times of square root of 1 minus e square. That's what I'm substituting here. So this will be 9 by 5. So 3 by 5 into 5. So this will be equal to 3. So b is equal to 3 we have got. Okay. So we have got a, we have got b. So equation of ellipse is x square upon a square plus y square upon b square is equal to 1. Now a is equal to 5 and b is equal to 3. That's what we have got. So x square upon a square, that means 25 plus y square upon 9 is equal to 1 is the equation of ellipse. That's how we solve it. So again, in tomorrow's class, we will continue ellipse and we'll see some portion of hyperbola. Thank you so much. Bye.
Sir.
Thank you, sir.